Hello everyone, welcome to the course on operating systems. We are in the topic of memory management, and in this session we are going to discuss about the static and dynamic loading, static and dynamic linking, and also static and dynamic binding. The first topic is the loading. First of all, let us understand what is the meaning of loading. Loading is the process of bringing the program from the hard disk to the main memory for execution. We all know that the program, whenever a program has to be executed, it has to reside in the main memory. So first of all, whatever the program that is there in the hard disk has to be brought to the main memory if it has to be executed. So who does the job of loading means there is a software called as the loader, and the loader brings the program from the hard disk to the main memory. And there are two different types of loading. One is static loading and the other one is dynamic loading. So in case of static loading, the entire program will be brought from the hard disk to the main memory. So here it requires more memory space because a program may consist of multiple functions. No matter whether all these functions are required or not, the entire program will be brought to the main memory. So in such a case, it requires more amount of space in the main memory. So the drawback of this type of static loading is the entire program and all data of a process must be in the physical memory for the process to execute. So here the size of the process is limited to the size of the physical memory. The meaning of this is if the physical memory size is some 1000 bytes, and if the program is occupying some 1500 bytes, in such a case you will not be able to execute that program because the program size is greater than the size of the main memory. So that is the drawback of static loading. And also for static loading, the starting address where the program has to be loaded in the main memory has to be known in during the compile time itself. And let us see the other type of loading, which is dynamic loading. And in case of dynamic loading, a routine is not loaded until it is called. For example, take a program that performs the calculator functionality, which includes multiple functions, including all arithmetic operations, addition, subtraction, multiplication, and division, and also some trigonometric functions, let us consider. So in such a case, at any given point of time, not all the functions will be used. Only certain certain functions of the calculator only will be used. So in such a case, whatever the functions that are required only will be loaded into the main memory. Whereas in case of static loading, the entire program, that means including each and every function of the calculator program, has to be loaded into the main memory. So there it requires more amount of space, whereas in case of dynamic loading, it requires relatively lesser space. So in this case of dynamic loading, we can still have programs which are having size bigger than that of the size of the main memory. So here the size of the program is not restricted by the size of the main memory. And the advantages include unused routines are never loaded. Consider our calculator example program. Whatever the functions that are not used will not be loaded into the main memory at all, though they are part of the program. And it is this kind of dynamic loading is especially useful when the program size is very large. And now let us move to the other next one, which is static and dynamic linking. So a linker is a program that takes one or more object files generated by a compiler and combines them into a single executable file. So if a program is using some third-party libraries, in such a case, whatever the object files of the present program and the object files of the third-party libraries will be linked together to form a single executable file. And in case of linking also, we have two different types. One is a static linking and the other one is dynamic linking. So in case of static linking, the linker combines all necessary program modules into a single executable program. So no matter whether these third-party libraries are required or not, all the executable files will be combined into a single executable program in case of static linking. On the other hand, in case of dynamic linking, there will be a program called as a small program called as a stub, which is included for each appropriate library routine reference. So whenever that particular routine is invoked, only then this stub links the corresponding executable file. So a stub is a small piece of code. When the stub is executed, it checks whether the needed routine is already there in the main memory or not. If it is there in the main memory, it will not link the executable file. Otherwise, if the routine is not available, then the program loads the routine into the main memory. So this is called as dynamic linking. Now let us understand these concepts with the help of a diagram. Initially, we'll be writing the source program, which will be compiled to create an object file, and the linker combines multiple object files. That means if the program is having some third-party libraries or it is using some inbuilt libraries, it will be having multiple object files. So the linker combines all these object files into a single executable file. And if this combining of the object files is done at runtime, then it is called as dynamic linking. And then this executable file, which is residing in the hard disk, has to be brought to the main memory, and which is the job of the loader. And if the loader brings the dynamically linked libraries to the main memory during the execution, then it is called as dynamic loading. So here you can see the compile time. The compiler is converting the source program into the object file, and during the load time, the object files are combined to form a single executable file, and then they are loaded into the main memory. And once the program is present in the main memory, it is ready for execution, and this is known as the execution time of the program. So having understood the concepts of static and dynamic loading and static and dynamic linking, let us move to the address binding. So address binding is a process of mapping one address space to another, and the linker and loader binds the relocatable address to the absolute address. So relocatable address is the address where the program is stored in the main memory. And on the other hand, absolute address refers to the address of the instruction within the program. So the binding of the instructions and data to memory address can be done at any step that we have seen in the previous diagram. So the binding of the data and instructions can be done either during the compile time or during the load time or during the execution time. So based on at what point of time the instructions and data are mapped to the memory addresses, we have different types of bindings, which include compile time binding, load time binding, and runtime binding. So in case of compile time binding, the starting address where the process will reside in the main memory is known at compile time itself. So this kind of compile time binding was used in earlier days where there were batch operating systems, in which case only one program will be executing in the main memory at any given point of time. So in such a case, the starting address where the program will be loaded is known during the compile time itself. And in case of compile time binding, if the starting location or the starting address of the program changes, then we need to recompile the code because whatever the physical addresses that are generated previously are not valid if the starting address changes. So this kind of compile time binding requires the recompilation of the code every time whenever there is a change of the starting address. And the next type of binding is load time binding. So the starting address where the program has to be loaded in the main memory is not known during the compile time. In such a case, the binding will be delayed until load time. So if the starting address changes, we just need to reload the user code to incorporate this changed value. So only the value of the relocation register needs to be changed whenever the program has to be loaded into a different region of main memory. So this is called as the load time binding, and the next one is execution time binding, which is the binding is delayed until the runtime. So this is required especially when the process are allowed to swap in and swap out between the main memory and the hard disk. So in such a case, whenever a process that is waiting is moved to the hard disk, and whenever it is coming to the running state again, it has to be brought to the main memory. So in such a case, there will be a change of address in the main memory for the process every time it is loaded into the main memory. And generally most of the operating systems use this type of binding, which is execution time binding. So with this, we came to the end of the session, and we'll meet again in the next session with another topic. Thank you.